Okay, let's look at section 4.3, number 14. Right, so you have this given function f of x equals cosine squared of x minus 2 sine of x, and x goes from 0 to 2 pi. Right, so let's try to find the interval on which the function is increasing or decreasing. All right, so we have to take the derivative. So f prime of x is equal to, right, derivative cosine square. So you have put the power in front, then you have a cosine of x, right? Then you multiply by its derivative, so it's going to be derivative of cosine is negative sine of x, right? Right, so derivative of negative 2 sine of x is negative 2 cosine of x. All right, then we factor out the common factor. So in this case, there's negative 2, so negative 2 is in common. So I'll put that, so it's negative 2 from the second term. So here's a negative 2 from the first term. Right, also there's a cosine of x here, and the first term also have cosine of x. So we should be able to pull out negative 2 cosine of x. Right, then what's left is going to be, you have sine of x right here from the first term. So sine of x. Then since we pulled out the negative 2 and the cosine of x, so what's left is just 1. Right. Then we can just set this equal to 0 to find the critical numbers. So set equal to 0. So we will get, all right, so we will get, let's see, there are two possibilities. We can let cosine equal to 0. Or, so let's say sine of x is negative 1. All right, so let's use the unit circle to find the x values. So let's draw a unit circle here. And here is the x-axis. And this is the y-axis. Right? So it's just a unit circle. So 1 here and 1 here, negative 1 there, and negative 1 there. All right. So remember that the cosine represents the x-coordinate of the point on the unit circle. So we want the x-coordinate to be 0. So the point on the circle that has x-coordinate 0 is this point, and also that point, right? So which means that the angle we're looking for would be right here, which is pi over 2, right? Or you can go all the way around to here, which is 3 pi over 2, right? So we have pi over 2 is one of them, and also 3 pi over 2. Right? How about the sine equal to 0? Sine of x equal to 0, right? So when sine equal to 0, we are looking for, oh, sorry, though this was not 0. We're looking for negative 1. Sorry about that. Right? Then the sine equals, the sine represents the y-coordinate of the point on the unit circle. So we want the sine to be negative. So it's actually this point right here. So angle is actually 3 pi over 2. All right, so we found critical numbers. So critical numbers are pi over 2 and 3 pi over 2. All right, So we're going to do a number line on this guy. So you do a number line here. Alright, so we only have to go from 0 to 2 pi. So I'll probably put 0 here and 2 pi there. Right? Then we put the pi over 2. So pi over 2 is right here. Pi over 2. And 3 pi over 2 is probably around here. 3 pi over 2. Right? So let's look at the sign. Right? So we're looking at the derivative here. So let's focus on here. Right? So we pick any number between 0 and pi over 2. So I would probably choose the pi over 4. So we plug in, look at the sign of derivative at the pi over 4. Right? So if it's x is pi over 4, which means 45 degrees, and pi over 4, then cosine is going to be differently positive. Right? And in pi over 4, then sine of x plus 1 is going to be differently positive, right? So we know that the negative 2 times positive, positive, so it's going to be negative, right? So the first derivative is going to be negative there, right? Then between pi over 2 and 3 pi over 2, I would probably try pi. So we look at the f prime of pi. All right, so cosine of pi is going to be negative 1, so it's going to be negative, right? And a sine of pi is 0 plus 1, so it's going to be positive, right? So negative 2, negative times positive would be positive, right? So we have a positive sign here, right? How about between 3 pi over 2 and a 2 pi? So I would probably pick a 7 pi over 4, right? So that's over here, right? We just want to know the sign, right? So cosine of 7 pi over 4, it's going to be on the fourth quadrant, so cosine is going to be positive, right? But the sine is going to be actually is negative, but still less than 1, so plus 1, so it's going to be positive here. So you have a negative times positive, so it's going to be negative. So f prime of 7 pi over 4 would be negative. So we have that. All right, so therefore we can answer the part A. So part A is going to, so I'm doing part A here. All right, so f is increasing, so f is increasing on interval, so between pi over 2 to 3 pi over 2. All right, and technically we can include pi over 2 and 3 pi over 2, but I think this textbook they want the open interval, so I'll do that. And a decreasing on interval from 0 to pi over 2 and 3 pi over 2 to 2 pi. Right? So that's the answer to part A. All right. Then using the first derivative test, since it's decreasing, so decreasing turned into increasing, so you're going to have a local right here. We're going to have a local minimum here. and increasing turn into decreasing. So at this critical number, you're going to have a local max. All right, so we can actually answer part B right away. So we're going to have a local maximum value would be, so local maximum value is going to be right here at x equals 3 pi over 2. So f of 3 pi over 2. Right? So this is going to be cosine is going to be 0. So it's going to be 0 squared. All right? Then negative 2 times, right? And a sine of 3 pi over 2 would be negative 1. Sine of 3 pi over 2 is negative 1 because right here. So we know that negative 2 times negative 1 would be positive 2. Right? So this is a local maximum value. How about the local minimum value? The local minimum value is going to be at pi over 2. So f of pi over 2, right? Cosine of pi over 2 is 0, again, so 0 squared, minus 2 times, right? Sine of pi over 2 would be 1. So local minimum value would be negative 2. All right, so let's do part C. Right, so intervals of concavity. So we need to look at the second derivative. So we take the second derivative, so another derivative. So f double prime of x is equal to, right? So we have this, so we're going to just go ahead and take the derivative of that. So you're going to get, let's see, negative 2 is outside, so I'll leave it there, right? Then we use the product rule to take the derivative. So derivative of cosine is negative sine of x, right, times the second, which is sine x of x plus 1, right, then plus, right, first guy is cosine of x times derivative of sine is another cosine of x, so times cosine of x. All right, so let's try to simplify this. All right, so you have, so I'm going to just go ahead and multiply this out. So you're going to get, all right, so negative 2 is outside. All right, then you have a sine, negative sine times sine, so it's going to be negative sine squared of x minus sine of x, all right, plus, all right, actually this is cosine squared, but it seems like everything is written in sine, so I'll try to write it. Cosine squared is the same thing as 1 minus sine squared of x, so I'm going to go ahead and put that in. So 1 minus sine squared of x. All right, and I'm going to incorporate this negative sign so that I'm going to turn this into, so this negative sign is going to be incorporated to negative sign. So this is going to be a positive sign. This is going to be a positive sign. This is going to be a negative sign. This is going to be a positive sign. Right? So what you get is, I'm going to go down here. Right? So there's a 2 in front. Then you would have, there's 2 sine squared. Right? You have a 2 sine squared of x. Right? Then you have a sine of x here. So plus sine of x. Then you have minus 1. Right? This guy, we can factor it out as 2 times All right, 2 sine of x and sine of x. All right, so it's going to be, let's see, we'll probably have to have +1 here, and we have to have -1 here. All right, so if you set that equal to 0, all right, so you can see that you're going to get all right, so one is sine of x has to be 1/2 to make this guy 0. So sine of x is 1/2, right? The other one is sine of x is equal to -1, right? We know this one. This one is going to be sine of -1, so x has to be 3 pi over 2, right? But the top one, we want sine of x to be 1/2. So let's draw another unit circle, right? Then again, sine value represents the y coordinate of the point on the circle. So we want that to be 1/2. So here's 1/2. Then you have these 2 points here and there, right? So angle here is going to be 30 degrees, so it's a pi over 6, all right? So that's this. But if you go all the way around to the other guy, so that's going to be 5 pi over 6. So here you get x equals pi over 6 and 5 pi over 6. All right, so let's do the number line for the second derivative. So you have to go from 0 to 2 pi, just like before. 0 to 2 pi. All right, then we have to mark 3 pi over 2, which is over here. All right, then you have pi over 6, so something right here, right there, pi over 6, and also 5 pi over 6, so somewhere around here. All right. All right, so we just want to figure out the sign. So if you put something smaller than 6 pi, right? So then this quantity is going to be, of course, negative, because the 6 pi makes it 1/2, but it's going to be smaller than that, so it's going to be negative, right? But this quantity is a +1 sign. You know, worst it can do is -1, so this is going to be actually positive. So you can see that it's a positive, negative, positive, so it's going to be negative here. All right, so I'm looking at the second derivative. All right, between pi over 6 and 5 pi over 6, I'll probably do pi over 2 or something like that. Then if you put pi over 2, so sine is going to be, let's see, pi over 2, so it's going to be 0. All right, so -1, so it's going to be still negative. So maybe I should erase that. And then, sorry, all right. So sorry, I said it again. So sine of pi would be actually 1. So you pi over 2 would be 1. So 2 times 1 minus 1. So it's actually positive. Sorry about that. All right. Then this guy is going to be positive. So everyone is positive. So sine here is going to be positive. All right. And then we can try something between 5 pi over 6 and 3 pi over 2. So it's going to be like a pi. So if you do pi, then sine is 0. So this is going to be negative. All right. Then sine of pi is 0 plus 1 is going to be positive. So you can see that it's going to be negative here. All right, after 3 pi over 2, again, we can try 7 pi over 4. All right, if you have 7 pi over 4, then you have, so the angle is over here. So sine is going to be, so this is going to be negative. right? Still negative, and but this guy is going to be plus 1, so it's going to be positive. So it's still negative here, right? All right, so interval of concavity. So you can see that it's f is. So therefore, so I'm gonna erase these guys. Oops, these guys. All right, so we know that. So therefore, f is, all right, concave upward on, all right, so between pi over 6 to 5 pi over 6, or concave downward on, all right, from 0 to pi over 6 and 5 pi over 6 all the way to 2 pi. All right. Then we have a couple of inflection points. You can see that the concavity changes happens at the pi over 6 and also 5 pi over 6, right? So there will be an inflection point there and another inflection point over here, right? So let's find the inflection points. I need the room here, so I'm gonna go up here. So I'm gonna erase this and try to find this. So this is the inflection point. So all I have to do is the corresponding y value. So f of pi over 6. All right, cosine of pi over 6 is square root of 3 over 2. Then you have to square that, and a minus 2 times sine of pi over 6 is going to be 1/2. Right? So you have square root of 3 square would be 3. 2 square would be 4. And minus 2 and 2 cancel out, so minus 1. So it's going to give you negative 1/4. And also we have to find f of 5 pi over 6, right? Cosine of 5 pi over 6 is actually negative square root of 3 over 2. Well, you have to square that, minus 2 times sine of 5 pi over 6 is going to be 1/2 again, right? So you got let's see that, and the same thing. It's if you square that, you get 3 over 4 minus 1. It's going to be negative 1/4, right? So therefore, inflection points are right, one of them is pi over 6 comma negative 1/4, and the other point is 5 pi over 6 comma negative 1/4. Right, those are the inflection points, and these are intervals of concavity. All right, that's it. I hope that this was clear.